Hi students, welcome back to my channel Evolve Solving Physics. Today we are going to discuss some important points based on object projected vertically upward. As we have discussed some motion parameters based on object projected vertically upward, that are maximum height, time of ascent, time of descent, time of flight. So that are the most important parameters when an object is projected vertically upward. We have discussed that as object is moving upward, then we consider the time as time of ascent, and for a downward motion we consider the time as time of descent. So based on that concepts, based on that motion parameters, we are going to discuss some important points which is very useful to you in multiple choice questions, solving multiple choice questions. So first one, in case of vertically projected body, velocity is maximum at projection point, velocity goes on decreases and minimum zero, that is zero at highest point. For suppose a body is projected vertically upward, this is an body projected vertically upward, as the body is projected vertically upward with initial velocity u, as the object is moving in upward direction. As the object is moving with initial velocity u in upward direction, here at the point of projection the velocity is maximum. As go on moving in upward motion, slowly the velocity will decreases at the highest point. At the highest point means at the maximum height, the velocity will becomes zero. The velocity will become zero, that is minimum. So this is the first point based on object projected vertically upward. As at the point of projection the velocity is maximum, as moving on upward motion the velocity slowly decreases, and at the highest point means at maximum height, the velocity will becomes zero, that is minimum. So next point, velocity at any point during the upward journey is equal to velocity at the same point during the downward journey numerically. So we all know that as object is projected vertically upward with initial velocity u, has reaches the maximum height v equals to 0, at freely falling u equals to 0. We all know that based on that concepts for a freely falling body and vertically projected body we have discussed in previous class. But numerically, when object is moving in upward direction at this point, when it is freely falling at the same point, the velocities will be equal. So this is moving with u velocity and this is falling with v velocity. So these two velocities at the same point, so the velocity at the upward journey is equal to the velocity at the same point. This is the first point which is projected vertically upward. This is the same point when it is traveling downward. So these two velocities will become same numerically, only numerically they are same, but only the numerical value of the velocities at the same point is same for the upward journey and downward journey. Okay, so velocity at any point during the upward journey is equal to velocity at the same point during the downward journey numerically. So numerically the velocities will be same at a same point for the upward journey and downward journey. For suppose if you consider this point and this point, this is an upward journey and this is an downward journey, these two velocities numerical values will be same for at the same point. We discussed in motion parameters that velocity striking is equal to v equals to minus u. V striking means when an object is thrown upward with initial velocity u, later on it reaches the maximum height and it freely falls and reaches the ground. In downward motion it freely falls and reaches the ground. This is the v striking. And when an object is in downward motion, when it reaches the ground, that velocity is called as v striking. So v striking is equals to minus u. We have discussed in previous class. But numerically, the projection velocity, that is u, is equals to striking velocity. Striking velocity means here downward motion when an object reaches the ground, that is taken as v striking. These two will be numerically equal. Numerical means in the form of numbers they are equal, but they travel in opposite direction. Why opposite direction? You will be obtained for the upward journey and v striking will be obtained in downward journey. So they are both in opposite direction, but numerical values, number values will be same. So this is the point. At the same point, the velocity at the upward journey is equal to velocity of the object at downward journey. So another important point is velocity at half maximum height. We know that the velocity at maximum height, the velocity at maximum height will be 0, but velocity at half maximum height is equal to u by root 2. When why we are obtaining u here, why we are getting u here? Because when an object is projected vertically upward with initial velocity u, as the object moves on in upward journey with u velocity, means decreasing velocity, at maximum height v will become 0. At maximum height v will becomes 0. What they said, that the velocity at half maximum height, we know that the distance traveled by the object is considered as height traveled by the object. So what this we are going to prove that velocity at half maximum height is u by root 2. We know that s equals to h maximum. We know that s equals to h maximum. We consider in maximum height that s equals to h maximum. The distance traveled by the object is, or displacement or distance. Why I am taking distance means here the direction represents here upward motion represents direction, so we can consider distance or displacement. The displacement traveled by the object in upward motion is considered as maximum height. But what they said, velocity at half maximum height means s equals to half maximum height. So the distance is taken as half maximum height. They said to prove that velocity at half maximum height as u by root 2. So the distance traveled by the object s equals to h we have taken. The total distance traveled by the object is taken as height of the body. But the distance traveled by the object is half maximum height. So s equals to half h maximum. We know that h maximum value is u square by 2g. So substitute here half u square by 2g. Now we are going to prove that velocity of half maximum height is u by root 2. So we know that it does not reach at maximum height, half maximum height. So for upward motion a equals to minus g. So a equals to minus g, s equals to half u square by 2g. Here they said to find velocity at half maximum height, that is v. Why we are calculating v here? It does not reach at the maximum height to become v equals to 0. They said to calculate velocity of half maximum height. So v equals to question mark. So next u equals to u itself. So when u becomes 0 for a freely falling body only, for a vertically projected body u does not become 0. So v square minus u square equals to 2as. V is v square itself. We are going to calculate v only. U is u square is equal to 2 into a is minus z. S is half u square by 2g. V square minus u square equals to minus 2. G will be cancelled here. 2 will be cancelled here. So minus u square by 2. V square minus u square equals to minus u square by 2. Send this minus u square to right hand side. V square equals to minus u square by 2 plus u square. Minus u square by 2 plus u square will be u square by 2. So if you take LCM 2 minus u square plus 2u square, minus u square plus 2u square will be u square by 2. So I'm making squaring on both sides. Squaring on both sides. What you will get? V square under root v square equals to under root u square by 2. Square root will be cancelled here. V equals to under root u square by under root 2. I am splitting it for numerator and denominator. Square root 2. Square and root will be cancelled. So v equals to under root v equals to u by root 2. So this is the velocity at the half maximum height. That is u by root 2. Okay. For suppose if they said to find the velocity of 3/4 of the maximum height, velocity of 3/4 of the maximum height, what you will take here? S equals to 3/4 h maximum. 3/4 h maximum means u square by 2g. So v square minus u square equals to 2as. A is minus g here for an upward journey only. V square minus u square equals to 2 into minus g into s is 3/4 u square by 2g. G. So 2 will be cancelled here. G will be cancelled here. So what you will get? V square minus u square equals to minus 3u square by 4. 3u square by 4. So send minus u square to right hand side. V square equals to minus 3u square by 4 plus u square. Make the LCM here. The LCM will be 4. Minus 3u square plus 4u square. What you will get? U square by 4. U square by 4. V square equals to u square by 4. Make squaring on both sides. What you will get? Under root v square equals to under root u square by 4. What you will get here? Under root v square equals to under root u square by 4. Square root will be cancelled. V equals to under root u square by under root 4. 4 can be written as 2 square. Square root will be cancelled. Square root will be cancelled. So velocity equals to u by 2. So this is the velocity at the 3/4 of the maximum height. That is v equals to u by 2. Means at this point v equals to u by 2. At the maximum height v equals to 0, and at the half maximum height v equals to u by root 2. So initially if an object is projected vertically upward with velocity u, the velocity at half maximum height will be v equals to u by root 2, and velocity at the 3/4 of the maximum height will be v equals to u by 2, and the velocity at maximum height equals to v equals to 0. These are the three important points when an object is projected vertically upward for the maximum height, half maximum height, and 3/4 maximum height. Based on this concept, you can solve the any way. For suppose if they said velocity of 1/4 of the maximum height means s is taken as 1/4 h maximum. So in the same way, you can calculate the velocity of the object at 1/4 of the maximum height. Now, so we are going to discuss one more important point when an object is projected vertically upward. For suppose the distance covered by the body projected vertically up in the first second of its upward journey is equal to distance covered by it in the by it means same object, by it in the last second of its entire journey is equal to u minus z by 2. Distance means, so what they are saying, s equals to u minus z by 2 will be when an object projected vertically upward at first second. For suppose an object is projected vertically upward with initial velocity u. This is the distance traveled by the object in first second. After reaching the maximum height, the object will fall freely in downward direction. and the distance traveled by the object at the last second of entire journey. When will be before of its reaching the ground of last second will be its entire journey. So distance covered by the body projected vertically upward in the first second of its upward journey is equal to distance covered by it. By it means by the same object in the last second of the entire journey. This is the entire journey, this is the last second. These two distances will be same. So now we are going to prove that. We know that for first second, for second second, for the last second, the formula for the distance will be Sn equals to u plus a into n minus 1 by 2. They said first second means n equals to 1. For upward journey, a equals to minus z. Substitute here. Yes, 1 is equal to u plus of minus z. N is 1 minus 1 by 2. S1 is equal to u minus g. 1 minus 1 by 2 will be 1 by 2. So S1 is equal to u minus g by 2. So this is the distance covered by the object vertically up in the first second is equal to u minus g by 2. This is for the object. This is for the distance traveled by the object in the last second. So this is the distance traveled by the object in first second of its upward journey is equals to u minus g by 2. So this is the first second of its upward journey and this is the last second of its downward journey. So these two distances will be equal. So S1 equals to u minus g by 2 for the first second of its upward journey and this value will be same for the last second of its downward journey, that is entire journey. So this is the last second of its entire journey or downward motion. So we got the value u minus g by 2. Why I am taking n equals to 1 only here to calculate S1 equals to u minus g by 2? We don't know the time for the last second. So we have considered the first second. So n equals to 1. If they say first second, second second, third second, you have to take the formula distance as Sn equals to u plus a into n minus 1 by 2. So the value for the first second of its upward motion and last second of its entire journey, that is downward motion, is equals to u minus g by 2. So the distance covered by the body projected vertically up in the last 1 second of its upward journey is equal to distance covered by it. By it means by the same object in the first second of its downward journey is g by 2. Now we are going to prove that. For suppose an object is projected vertically upward with initial velocity u. So at this point it reaches a maximum height v equals to 0 and the object is falling freely in downward direction and reaches the point of projection, that is ground. So at this point, after reaching the maximum height, when it is freely falling, u will become 0 and this will be v. What they said, distance covered by the body vertically up in the last second. Let us consider this as last second, last 1 second of its upward journey is equal to distance covered by it first second. First second means first second of its downward journey. This will be the first second of its downward journey. So this is the first second of its downward journey. So these two will be equal, that is equal to g by 2. We can't, so first second we can take the formula of Sn equals to u plus a into n minus 1 by 2. So we don't know the last 1 second. Last means has how much distance, how much time does it has traveled, we don't know. What will be the last 1 second? So we consider the downward motion of the first second. So for downward motion, you all know that for downward motion u equals to 0, a equals to z. So last second n equals to first second last second of its upward journey is equal to distance traveled by the first second of its downward journey. So n equals to 1. Substitute here. S1 equals to 0 plus g into n is 1 minus 1 by 2. S1 equals to g into 1 minus 1 by 2 is 1 by 2. So S1 equals to g by 2. So here it is clear that the distance traveled by the first second of its downward journey is g by 2. So these will be equal to the distance traveled by the last 1 second of its upward journey. So the value will be g by 2 only. So the two values will be same. So the distance traveled by the last 1 second of its upward journey is equal to the distance traveled by the first second of its downward journey is equal to g by 2. If you know one value, the another value will be same when last 1 second of its upward journey is equal to distance traveled by the first second of its entire journey, that is g by 2. So we discussed that when an object projected vertically up, the velocity at 3 by 4th of the maximum height, we have calculated that velocity of 3 by 4th of the maximum height is u by 2, that is this. So velocity of 3 by 4th of the maximum height is v equals to u by 2. We got the velocity of 3 by 4th of maximum height is u by 2. Now we are going to discuss time taken by the vertically projected upward body to reach 3 by 4th of the maximum height. There we found the velocity of vertically projected upward body of 3 by 4th of maximum height. We found the velocity at 3 by 4th of the maximum height. Here we are going to find time when an object is projected vertically up, the time taken to reach the 3 by 4th of the maximum height. So this is the 3 by 4th of the maximum height. Here we are going to find the time here. We found that velocity at the 3 by 4th of the maximum height is u by 2 and the velocity at half maximum height is v equals to u by root 2. These are the velocities at 3 by 4th of the maximum height is u by 2 and the velocity at half maximum height is u by root 2. At these points we are going to calculate the time here. So we know that for upward motion v equals to v and u equals to u and a equals to minus g. Okay, now we are going to calculate the time here. V equals to u plus at and v equals to u. V is v here. V will be 0 only at maximum height. The v will not be 0 at 3 by 4th of the maximum height and half maximum height. The velocity will be, the final velocity will be only 0 at maximum height. The final velocity will not be 0 at 3 by 4th of the maximum height and half maximum height. Even initial velocity when it is freely falling at maximum height and it is freely falling, u equals to 0. Okay, so v equals to u, u is u, a is minus g and t is t. So we are going to find the time taken by the vertically projected upward body to reach 3 by 4th of the maximum height. We know that the velocity at 3 by 4th of the maximum height is u by 2. So u by 2 is equal to u minus gt. Why I am substituting here u by 2? Because this is the velocity at 3 by 4th of the maximum height. By using this we are going to calculate time at the 3 by 4th of the maximum height. So now we want t here, that is the time taken by the body to reach the 3 by 4th of the maximum height. Send this u to left hand side. U by 2 minus u equals to minus gt. U by 2 minus u is minus u by 2 equals to minus gt. We want t here. As g is multiplying, I am sending to left hand side, it will divide. Minus u by minus 2g. Minus minus will be cancelled. T equals to u by 2g. So t equals to 1 by 2 u by g. 1 by 2 into u by g is same as u by 2g. Has u by g, what is u by g? Time of ascent. So ta half ta. So t equals to ta by 2. This is the time taken by the body when vertically projected up to reach the 3/4 of the maximum height is t equals to ta by 2. Now we are going to calculate the time taken by the body to reach the half maximum height. Half maximum height is v equals to what we are going to take here, v equals to u by root 2. So v time t for half maximum height. So for half maximum height the velocity will be u by root 2. So u equals to u here. So I am taking v equals to what we have to take here, v equals to u by 2. Why I am taking u by 2? So the velocity at 3/4 of the maximum height is u by 2. So I am substituting v equals to u by 2 here. So here I am substituting v equals to u by root 2. Why? Because this is the velocity at half maximum height, that is u by 2. So u equals to u, a equals to minus z because it is vertically upward. V equals to u plus at. Substitute these values. V equals to u by root 2, that equals to u is u minus gt. Okay. Send this to left hand side. U by root 2 minus u equals to minus gt. Take minus as common. Minus u by root 2 plus u is equal to minus gt. Minus will be cancelled. When you multiply these minus, you will get the upper value. Minus into minus plus minus plus minus. So I am taking common here. So you can write it as u minus u by root 2 is equal to gt. You can take the common value of u. You have u in both the terms. U equals to 1 minus 1 by root 2 is equal to gt. So I am sending g to left hand side. It is multiplying. As it sent to left hand side, it will divide. U by g into 1 minus 1 by root 2 is equal to t. 1 by u is ta. Why I am taking ta here? Why I am not taking td? Td means time of descent. Because here we are calculating the time when an object is thrown vertically up. Vertically up means time of ascent. For downward motion means time of descent. So we can take vertically projected up means we can take only time of ascent. Vertically projected downward means we can take time of descent. For complete time means we can take time of flight. So I am taking ta here. So why I am taking ta means the object is projected vertically up. The time will be time of ascent. So u by g is ta. Ta into 1 minus 1 by root 2 equals to t. So t value is ta into 1 minus 1 by root 2. This is the time taken by the body when vertically projected up. For the half maximum height, the time will be t equals to ta into 1 minus 1 by root 2. You want value of this means 1 by root 2 means 1.414. You can divide and subtract with 1. You get the numerical value. So these are the times for 3/4 of the maximum height and half maximum height when an object is projected vertically upward. So projected vertically upward means we only take the time of ascent. Okay. We can calculate these times for vertically up for 3/4 and the maximum height and half maximum height by using only velocities at the 3/4 of the maximum height and velocity of half maximum height. So here we are taking v as u by 2 and here we are taking v as u by root 2. These are the velocities at 3/4 of the maximum height and half maximum height. Now we are going to find the relation between maximum height and time of flight. We are calculating some expression to find the relationship between maximum height and time of flight. When we get time of flight, when an object is projected or when an object is thrown vertically upward and after reaching the maximum height, it freely falls in downward direction and reaches the ground. The time taken by the total journey is taken as time of flight. So we are calculating the relationship between T, capital T and H maximum. So you all know that we know that time of flight value is 2u by g. 2u by g. And H maximum is u square by 2g. Consider time of flight t as 1 and this is 2. From 1, t equals to 2u by g. I am writing this equation in terms of u. Sending g to left hand side, gt is equal to 2u, u equals to gt by 2. Equation 3. Substitute 3 in 2. 2 is maximum height. So H maximum is equal to u square by 2g, and u is, what is u here? gt by 2 whole square by 2g. So what you will get here? G square t square by 2 square is 4 into 2g. What you will get here? G square t square by 8g. Gg will be cancelled here. So what you will get here? H maximum is equal to 1 by 8 gt square. So this is the relationship between maximum height and time of flight. So if you can get this question in terms of multiple choice question. What is the relationship between maximum height and time of flight is H maximum equals to 1 by 8 gt square. So you know that maximum height formula is u square by 2g, time of ascent is u by g, time of descent is u by g, time of flight is 2u by g. I said that time of flight can be denoted by capital T or TF. And relationship between half maximum height and time of flight will be 1 by 8 gt square. These are the 4 formulas which are mainly important used in problem solving. So this is the relationship between capital T, that is time of flight, and maximum height, that is H maximum equals to 1 by 8 gt square. So these are the some important points when an object is projected the vertically upward direction. So if you have any doubts, please comment me in comment box. Please like, share and subscribe my channel. Thank you.